Welcome inside the Boeing 747, engineering the world's most famous airliner. Today we're going to be talking about the don't forget the hit. That subscribe button most of y'all have been watching, but ain't subscribing. It would much appreciated and make my day another than that. Have a good day. Let's get started. The Boeing 747 isn't just another airplane. For more than 50 years, it carried presidents, celebrities, astronauts, and hundreds of millions of passengers across every continent on Earth. Nicknamed the Queen of the Skies, the 747 completely changed commercial aviation. Its iconic upper deck, enormous size, and unmatched presence made it one of the most recognizable aircraft ever built. But have you ever wondered what makes a Boeing 747 so incredible? Today, we're taking an inside look at the engineering behind this aviation legend, from the massive landing gear that supports nearly 1 million pounds to the luxurious cabin advanced passenger seats, emergency safety systems, and even the tiny windows that somehow withstand unbelievable pressure at 35,000 feet. Let's step inside one of the greatest machines ever created. Chapter 1. The Beginning. The story of the Boeing 747 began during the 1960s. Air travel was exploding in popularity. More people wanted to fly than ever before, and airlines desperately needed an aircraft capable of carrying hundreds of passengers over extremely long distances. At the time, Boeing accepted what many believed was an impossible challenge: design the largest passenger airplane the world had ever seen. Thousands of engineers spent years creating an aircraft unlike anything before it. When the Boeing 747 entered service in 1970, the aviation industry changed forever. The aircraft stretched more than 230 feet long. Its wings reached nearly 200 feet across. Standing almost as tall as a 6-story building, passengers had never seen anything like it. The famous hump on the front wasn't originally designed to be luxurious. Engineers expected supersonic aircraft to replace passenger jets one day, so they designed the cockpit on the upper deck, allowing the nose to open upward for cargo loading if needed. Ironically, that engineering decision became one of the most iconic designs in aviation history. Chapter 2. The Incredible Landing Gear. One of the first things you'll notice underneath the Boeing 747 is its enormous landing gear. Unlike smaller aircraft that may have only 3 landing gear assemblies, the Boeing 747 rides on an incredible 18 wheels. Why so many? Because when fully loaded, the aircraft can weigh nearly 1 million pounds. Imagine placing that weight onto only a few tires. The pavement would suffer tremendous damage and the aircraft would become unstable. Instead, Boeing spreads the weight across 18 tires, 4 wheels under the nose, 4 main landing gear, assemblies beneath the wings and fuselage. Each wheel helps distribute the massive weight more evenly during takeoff, landing, and taxiing. The landing gear itself is a masterpiece of engineering. Each shock absorber is filled with hydraulic fluid and nitrogen gas, allowing it to compress during touchdown. Instead of passengers feeling a violent impact, the landing gear absorbs enormous landing forces within seconds. During flight, the entire landing gear folds neatly inside the aircraft, using powerful hydraulic systems. Massive doors then close to improve aerodynamics and fuel efficiency. Chapter 3. The Evolution of the Cabin. While the outside impresses aviation enthusiasts, the inside impresses everyone else. Early Boeing 747. Cabins completely changed the passenger experience. For the first time, airlines could create spacious cabins with wide aisles, multiple seating classes, lounges, cocktail bars, and even piano areas. Over the decades, passenger seating evolved dramatically. Modern seats are designed using lightweight aluminum alloys, carbon fiber composites, titanium components, high-density foam, fire-resistant fabrics, and advanced engineering that balances comfort with weight savings. A single economy seat may appear simple, but it contains dozens of individual parts: foldable tray tables, entertainment systems, electrical wiring, USB charging, reading materials, life vest compartments, adjustable headrests, reclining mechanisms, and structural reinforcements capable of protecting passengers during severe turbulence. Each seat must survive crash testing that subjects it to forces far greater than normal flight conditions. Every kilogram saved across hundreds of seats reduces fuel consumption over millions of miles. Chapter 4: The Luxury of the 747. Although economy passengers enjoy impressive comfort, the premium cabins take luxury to another level. Many airlines transformed the Boeing 747 into a flying hotel. First-class passengers often enjoy fully flat beds, private suites, large entertainment screens, fine dining served on real plates, premium bedding, mood lighting, quiet cabins, and personalized service. Some VIP versions of the Boeing 747 go even further. Private owners have installed conference rooms, master bedrooms, showers, dining rooms, lounges, offices, and even private medical facilities. Several heads of state operate customized Boeing 747s that function as flying government headquarters. The aircraft's enormous size makes all of this possible. Very few passenger airplanes have ever offered this much interior space. Chapter 5: Safety above the ocean. Crossing oceans presents unique challenges. If an emergency water landing ever became necessary, every second counts. That's why every Boeing 747 carries emergency flotation equipment. Life vests are located beneath or near each passenger seat. Passengers simply pull the vest over their head, fasten the straps, and inflate it only after leaving the aircraft. Inflating inside the cabin could make evacuation much more difficult. For longer international flights, inflatable life rafts are also stored inside dedicated compartments. During an emergency, flight attendants remove the packed raft, attach it securely to the aircraft, and throw it outside. Once deployed, a gas cylinder rapidly inflates the raft within seconds. These rafts include survival kits containing drinking water, first aid supplies, signaling equipment, paddles, repair materials, and emergency food rations. Every crew member regularly trains for these unlikely situations. Thankfully, commercial aviation remains one of the safest forms of transportation ever created. Chapter 6: How airline seats are made. Building an airline seat is far more complicated than building furniture. Manufacturers begin with precision aluminum or composite frames. Every piece is designed using computer simulations before a single part is produced. The frame is then assembled using high-strength fasteners and reinforced joints. Next comes the foam cushioning. Unlike ordinary household furniture, aviation foam must meet extremely strict fire-resistance standards. The upholstery is also specially engineered to resist flames while remaining durable after years of daily use. Electrical systems are then installed. Power outlets, reading lights, seat controls, entertainment displays, USB ports, and communication wiring. Finally, every completed seat undergoes extensive testing. Manufacturers repeatedly recline it, apply thousands of pounds of force, and simulate years of passenger use before approval. Some seats experience the equivalent of decades of operation during laboratory testing. Chapter 7: The Amazing Window Design. One of the smallest parts of the Boeing 747 is also one of its most impressive engineering achievements: the passenger window. At cruising altitude, the air outside is incredibly thin. Temperatures can fall below -60 degrees Fahrenheit. Meanwhile, inside the cabin, passengers remain comfortable at room temperature. This creates an enormous pressure difference. Every window must constantly resist that force throughout the flight. Instead of using a single sheet of glass, Boeing uses multiple transparent acrylic layers. The outer pane carries most of the structural load. The middle pane acts as a backup. The inner pane protects passengers from scratches and damage inside the cabin. You may have noticed the tiny hole at the bottom of every passenger windows. This is called a bleed hole. It allows pressure to equalize between the window layers, ensuring the strongest outer pane carries the majority of the load while reducing stress on the inner panels. Without this simple engineering feature, the windows would experience much greater stress every flight. The rounded shape of the windows is equally important. Sharp corners concentrate stress, distribute pressure much more evenly, significantly reducing the risk of cracks forming over thousands of pressurization cycles. Every time a Boeing 747 climbs to cruising altitude and descends again, the fuselage expands and contracts slightly. The windows are specifically engineered to withstand these repeated pressure cycles for many years. It's a remarkable example of how even the smallest design details play a critical role in aviation safety. The Boeing 747 became much more than a passenger airplane. It became a symbol of innovation, engineering, and human ambition. From its 18-wheel landing gear and luxurious cabins to its advanced passenger seats, life-saving safety systems, and pressure-resistant windows, every part was designed to move hundreds of people safely across the world. Although production has ended, the Queen of the Skies continues flying cargo, government, and special missions. Its legacy lives on and will never be forgotten. If you enjoyed this video, subscribe to Expensive Metal Crafts, and tell us what aircraft we should explore next. Thanks for watching, and we'll see you in the next video.